In the fragile interval between survival and death, the body enters a state unlike any other moment in life. Biological systems do not collapse all at once, but in a rapid chain of shutdowns that follow a recognizable sequence. Electrical rhythms vanish, circulation halts, and oxygen supply to cells disappears within seconds. Neurons, the most energy-hungry cells, fail nearly immediately. The networks linking thought, memory, and identity begin to falter. From a clinical view, this looks like silence, a flatline that would, under traditional models, mean the end of conscious experience. Yet at the very same time, an unexpected puzzle appears. Many survivors later describe structured, vivid experiences during this period when life functions appeared unavailable. In emergency rooms, intensive care units, and other critical care settings, patients brought back after resuscitation sometimes share accounts that defy what physiology should allow. They do not sound like brief, chaotic flashes. Instead, many describe coherent episodes, awareness of movement, perception of an expanded reality, or even detached perspectives as though watching events unfold from outside the body. Prospective studies of cardiac arrest survivors and retrospective reviews of thousands of patient reports consistently document recurring motifs. Yet not everyone who undergoes cardiac arrest recalls such experiences, and researchers stress that the phenomenon is complex, inconsistent, and contested. Still, patterns have emerged across decades of observation. People separated by culture and geography often describe similar sensations: detachment from the body, calmness, encounters with light or vastness, and awareness that feels heightened rather than diminished. These reports challenge simple models of the brain producing hallucinations as it shuts down. Dreams and drug-induced hallucinations are typically chaotic, scattered, and shaped by cultural reference points. But near-death accounts, even from distant regions with little exposure to the concept, show repeating structures. This does not by itself prove a metaphysical explanation, but it raises questions science cannot yet fully answer. The central tension is clear. Clinicians document organs ceasing to function, while survivors speak of something opening in those very moments. Medicine treats cardiac arrest as an end stage to reverse. Patients describe it as the beginning of a different kind of awareness. For scientists, anecdote cannot be evidence on its own, but the volume of consistent reports across varied backgrounds makes it impossible to simply dismiss the phenomenon. It is not a matter of one or two unusual cases, but of thousands described independently, with striking overlap. Recent clinical studies have also introduced measurable data to this question. Several research teams monitoring cardiac arrest have recorded brief surges of organized neurophysiological activity at the time circulation ceases. These spikes, in some cases lasting tens of seconds, suggest that the brain may produce patterns of activity even when blood and oxygen supply are collapsing. Such findings complicate the lights-out assumption, forcing scientists to consider whether consciousness may persist in ways not previously understood. When researchers examine the frequency of these experiences, a consistent range appears. Prospective hospital-based studies of cardiac arrest survivors suggest that reports of near-death type experiences occur in about 10 to 23% of cases. Studies in intensive care and among survivors of critical illness find slightly lower numbers, often in the mid-teens. These figures, while not universal, represent a substantial fraction that deserves attention. They confirm that near-death experiences are neither fringe anomalies nor inevitable outcomes, but recurring phenomena that accompany certain critical states. The documented accounts often include episodes of apparent perception beyond physical senses. Some patients vividly describe actions taken by medical staff during resuscitation, occasionally recounting details later confirmed by those present. These cases are controversial, but their consistency across different hospitals and research groups prevents them from being dismissed outright. For skeptics, they highlight the difficulty of memory and perception under trauma. For others, they open the possibility that awareness during clinical death does not vanish with brain activity alone. Large collections of reports underscore these debates. Independent research groups have compiled repositories with tens of thousands of first-hand accounts spanning multiple continents. Analysis of these datasets reveals repeating motifs: light, expansion, encounters with presences, impressions of review or judgment, and detachment from the body. Many of these themes transcend cultural influence, appearing from societies with no strong tradition of near-death narratives. While interpretation varies, the structures themselves repeat with enough regularity to demand explanation. From a strictly neurobiological view, the paradox grows sharper. If consciousness is dependent on continuous brain function, then coherent experience during flatline should not occur. Yet survivors return describing episodes that feel even more vivid than normal waking life. Neurobiology's current challenge is to integrate reports of heightened awareness with evidence of failing electrical activity. Some theories suggest final cascade effects in the brain could briefly generate complex experiences. Others propose that biology alone may not be the full story, hinting that consciousness could involve mechanisms science has not yet mapped. The personal impact of these episodes cannot be ignored. Survivors often describe lasting changes in perspective, values, or priorities following their experiences. To them, these moments were not confused illusions, but encounters with a reality that carried profound meaning. Even if science continues to treat the phenomenon cautiously, the lived conviction of those who experienced near-death states speaks to a dimension of human life not easily quantified. As the clinical and anecdotal records accumulate, researchers across multiple fields are being prompted to reevaluate assumptions. Psychologists explore whether archetypal structures in the human mind could generate similar imagery under duress. Neuroscientists weigh evidence of transient neural surges against the persistence of ordered memories. Physicians document the challenge of treating patients whose reports blur the boundaries of biological shutdown. And philosophers consider whether near-death experiences point toward properties of consciousness that extend beyond reductionist models. What is clear for now is that these reports consistently highlight a frontier at the edge of life. Within the silence of the stopped heart, many survivors describe experiences not easily reduced to chaos or fading consciousness. Instead, they describe moments that feel structured, meaningful, and surprisingly consistent across populations. This raises one of the most striking questions science now faces. If each brain deteriorates differently, why do the reports so often share the same themes? That question takes us into the heart of the next mystery: how individuals of different cultures and beliefs, undergoing unique biological declines, can still describe a set of near-death experiences that appear astonishingly alike. Universal themes that defy borders. Researchers began noticing that despite differences in background and context, near-death accounts carry themes that repeat with remarkable steadiness. This raises the question of whether certain motifs, light, unity, and expansion, represent universal patterns within human consciousness rather than random products of a failing brain. These recurring images and sensations, observed in thousands of narratives, have become known as the universal themes that defy borders. One of the most consistent motifs is the image of light. Across compiled case studies and global databases of reports, a majority of people describe a radiant presence or brilliance that is comforting rather than painful. For some, the light envelops them completely. For others, it appears as if at the end of a tunnel or pathway, pulling them toward it. The descriptions often emphasize qualities of warmth, meaning, and an undeniable sense of presence. Phenomenological and comparative studies confirm that luminous encounters arise across religious and cultural contexts. In Christianity, the light is sometimes interpreted as divine. In Hinduism, it may be described in terms of deities. In Buddhist traditions, it can be framed as boundless awareness. Even among those with no religious background, the structural qualities of the experience remain steady: brilliance, presence, and expansion into something greater than ordinary perception. Another widely documented theme is unity, or the sense of merging with something beyond individual identity. Many survivors describe boundaries between self and environment dissolving. For some, this feels like becoming part of a vast consciousness. For others, it is subtler, an intuitive sense of everything being interconnected. Though cultural language varies, research notes that people consistently portray unity as more real than waking life, not as a dreamlike blur. Clinical databases and retrospective accounts confirm that this sense of expanded selfhood is among the most frequent features, alongside light and out-of-body experiences. Equally striking are the reports of entering immense cosmic spaces. Some describe star-filled expanses, others endless voids alive with presence, and some even moving through realms of energy. The imagery shifts depending on personal vocabulary, but the underlying experience, a sudden scale shift beyond the personal, appears stable. Scholars note similarities to the overview effect, described by astronauts seeing Earth framed against the vastness of space. They often report awe, a dissolving of boundaries, and deep feelings of planetary unity. Similarly, physicists encountering unexpected patterns in their data sometimes describe sensations of stepping briefly into a hidden order. These echoes across entirely different settings suggest that the sense of expansion may reflect a fundamental capacity of consciousness under certain conditions. The resemblance among these accounts encouraged researchers to consider whether the patterns are archetypal, a set of experiences rooted in human psychology or perhaps in something deeper. Archetypes are not random but structured motifs appearing across cultures and history. In the context of near-death experiences, light, unity, and vast expansion act as repeatable patterns that cut across time and geography. Phenomenological reviews confirm that while interpretive layers vary by belief system, the core features remain remarkably consistent. Culture shapes the narrative details, but the skeleton of the experience holds steady: light, out-of-body awareness, unity, and in some cases a life review. Not all explanations turn to archetypes, however. Some neuroscientists emphasize physiological models. One influential line of research links near-death features to REM intrusion, instances when features of vivid dream states intrude into waking consciousness. Studies have shown that people who report near-death experiences are more likely to display REM-related traits such as out-of-body sensations or vivid imagery. This hypothesis suggests that certain brain mechanisms could predispose individuals to structured experiences during extreme stress. That does not account for every element described, but it highlights a plausible biological route for features like floating above the body or entering vivid dreamlike environments. Within large case collections, frequency patterns highlight a striking consistency. Light, unity, and expansive space repeatedly appear as the most durable motifs. Other features, such as landscapes, encounters with beings, or life reviews, vary more widely depending on culture and expectation. In some traditions, people meet familiar religious figures during their experiences, while in secular contexts they might describe presences without defined form. Comparative reviews emphasize that the interpretive layer rests on cultural familiarity, but underneath, the experiential elements point in similar directions. If the shutdown of a brain were simply the random static of dying neurons, then the reports should be chaotic and unpredictable. Yet what emerges are structured, repeatable experiences described as clearer than ordinary reality. A growing number of scientists suggest this tension cannot be ignored. Either the brain under crisis generates patterned experiences through mechanisms not yet fully understood, or consciousness is revealing some shared layer beyond biology. The debate turns on whether these motifs are biological archetypes playing out within neural activity, or glimpses of something not contained within individual minds at all. What makes these themes important is not only what they reveal about dying, but also what they suggest about living. If the most critical thresholds bring forth visions of unity and connectedness, it may reflect a potential embedded in all human consciousness. Just as astronauts and scientists describe awe when confronting vastness or hidden order, patients nearing death describe similar revelations in personal terms. Light, unity, and expansion seem to appear at the points where ordinary boundaries collapse, whether physical, psychological, or existential. Taken together, the case databases and comparative reviews provide robust documentation that near-death experiences are not random or culturally invented fictions. Instead, they contain a small set of motifs that recur with surprising stability. Light, out-of-body awareness, unity, expansion, and occasionally life review form the backbone of the reports, while interpretation overlays them. The presence of such regularity across traditions and geographies suggests that, whatever their root cause, these are not isolated fantasy episodes, but tap into foundational aspects of human experience. For researchers, the question is whether current models of the brain are capable of explaining these patterns. If neurological collapse simply generated random noise, the consistency would be hard to account for. Yet attributing it solely to something beyond biology also raises challenges. This is where the debate now stands, between archetype and mechanism, between psychology and physiology. As scientists examine these recurring features, they confront the persistent gap between the structured clarity people describe and the expected chaos of a faltering brain. That gap has become the next major puzzle, driving new research into how the brain behaves in the boundary state between life and death. The neuroscience puzzle. For scientists, this is where the unresolved puzzle of the brain comes into focus. Neuroscience finds itself confronted by data that do not sit easily with its established models. For decades, the common assumption was straightforward. Near-death experiences arise from misfiring neurons when oxygen levels drop. Hypoxia, the shortfall of oxygen in brain tissue, can disrupt normal signaling and produce distorted perceptions. Add to this the surge of neurotransmitters like endorphins, which can dampen pain and induce calm, and a plausible picture emerges. As death approaches, brain activity fragments and we experience fleeting, internally generated visions. For a long time, this explanation seemed sufficient. Hallucinations resembled dreams or anesthesia, fleeting, confused, untethered from external reality. But findings in recent years, including studies conducted up to 2025, suggest this view may be incomplete. Several small studies in both animals and humans have recorded transient, highly organized neural surges at the point of clinical death. In rodents, for example, researchers documented concentrated gamma-band activity seconds after cardiac arrest. Human evidence is more limited, but has shown similar signals: short-lived, coherent bursts from frontal and temporal brain regions following cardiac failure. These were not random noise. They were structured, synchronized waveforms, sometimes involving areas linked to memory, vision, and sense of self. Importantly, these results are not yet definitive. The samples are small, the recordings rare, and interpretation remains cautious. Yet the fact that any organized surge occurs when silence was expected challenges the simplest explanations. The surprise is that hallucinations caused by chemical imbalance tend to be brief and forgettable, whereas near-death accounts are often detailed, ordered, and vividly remembered years later. Many patients report sequences of events unfolding with narrative clarity, traveling toward light, encountering presences, experiencing vivid reviews of life. Clinically speaking, a brain in collapse should not be generating experiences that resemble carefully staged stories. It should be producing fragments, flashes, confusion, incoherence. That gap between expectation and report is what neuroscientists now struggle to reconcile. Some researchers propose that the surge of organized brain activity reflects the system's last effort to maintain order. Others suspect the opposite, that near-death conditions lift the brain's normal filters. In everyday life, sensory information is continuously compressed so that we are not overwhelmed. Perhaps dying lowers the filter, exposing raw streams of data and widening the subjective field of awareness. Patients' descriptions of experiences, more real than real, or sudden expansions of consciousness could reflect this drop in constraint. Either way, the findings point to something different from total collapse. Another complicating detail is the durability of memory. Neurochemical hallucinations typically fade fast. They are difficult to recall and carry little lasting meaning. By contrast, near-death memories are often etched deeply, remembered vividly decades later with emotional force. The brain normally struggles to cement impressions under stress, yet here it appears to leave enduring marks. Basic neurobiology does not easily explain why moments of flatline might burn so deeply into memory. A further contested area involves veridical perception, cases where patients under cardiac arrest report accurate details about medical procedures or conversations occurring around them. Prospective studies attempting to test such claims have even used hidden targets in hospital settings. Most participants reported nothing, and only a handful of cases surfaced where patients described verifiable details. These remain rare, isolated, and debated. Possibilities such as misremembered fragments, chance overlap, or later reconstruction cannot be ruled out. Even so, the few corroborated examples keep researchers cautious. They may not constitute proof of perception beyond the physical senses, but they raise intriguing questions about awareness during apparent unconsciousness. The evidence in humans builds on what was first hinted at in animals. Rats turning flatline showed an intense, coordinated spike in gamma synchronization, a high-frequency activity usually tied to attention and conscious processing. Human case series now suggest similar brief patterns around cardiac arrest, though research is far less advanced. These findings are anomalies, not conclusions. They show that the brain's transition through death contains activity we do not yet understand. It is not silence from start to finish. Something systematic happens in the seconds after the heart ceases. Subjective accounts add another dimension. Instead of scattered impressions, many survivors describe narratives that feel coherent and ordered. Review of one's life from early childhood to the present, perceived encounters with light or beings, movement through structured environments. These are not typical dream fragments. Patients insist they occur in sequence, carry meaning, and feel more real than waking life. For neuroscientists working within materialist frameworks, this is difficult. The models predict a brain short-circuiting, not constructing stories with beginning, progression, and resolution. Some in the field have begun to explore hypotheses that shift how we view the brain's role. Rather than generating consciousness entirely, the brain may regulate, filter, or constrain it. As the physical system deteriorates, the filtering weakens and experience is broadened in ways unavailable during ordinary waking life. This filter, or receiver, model remains speculative, criticized for reaching beyond the bounds of empirical neuroscience. Still, the discovery of unexpected neural surges at death means any explanation must remain provisional. At the center of the debate is the simple contrast between expected chaos and observed coordination. Clinicians anticipated stillness, recordings showed order. Psychologists expected confusion, patients described clarity. Neuroscience cannot yet resolve the contradiction. What it has found are brief episodes of structured brain dynamics that might help explain the vivid, organized experiences some patients recall. Just as importantly, it has found the limits of its current tools. There is still no established way to link real-time brain signatures to a patient's reported near-death vision, and the field openly acknowledges this gap. Controlled prospective studies of cardiac arrest patients are ongoing, and many experts stress the need for replication before sweeping conclusions can be drawn. What these anomalies establish is not a proof of consciousness beyond the brain, but a problem worth pursuing. They show that standard models of dying as simple shutdown do do not match what is observed in detail. The brain may briefly organize itself in ways we did not predict, or we may need new frameworks for what consciousness is and how it operates. These possibilities remain open. The puzzle, therefore, is no longer whether near-death experiences are real, but how closely they align with underlying biology. The evidence points to unusual neural dynamics, vivid and lasting memories, and occasional reports of perception when perception should not occur. Each of these features pushes the discussion further from easy dismissal, placing the phenomenon within the boundaries of real scientific inquiry. As debates continue in neuroscience, other fields have begun to take notice. The persistence of structured experience where none should exist has drawn unlikely participants into the conversation. Physicists, usually occupied with quantum particles and cosmological models, now find themselves drawn into questions once seen as strictly medical. Their theories raise an even bolder possibility, that the brain's anomalies may point to links between consciousness and the fundamental fabric of reality itself. Quantum theories of consciousness. Few anticipated that physicists, trained to focus on particles and quantum fields, would find themselves drawn into discussions about near-death experiences. Yet in recent years, some theoretical researchers have paid attention to consistent patterns seen in patient reports. It isn't the narrative detail that interests them, but the striking regularity, visions of light, dissolving boundaries, and a sense of interconnectedness. For scientists already grappling with quantum mechanics, where phenomena defy ordinary assumptions about distance and time, such patterns suggest possible parallels worth examining. Still, it is necessary to state clearly at the outset, quantum-based models of consciousness are highly speculative, not widely accepted in neuroscience, and remain more a matter of interdisciplinary exploration than firm explanation. Among the ideas often referenced is quantum entanglement. This effect, demonstrated in laboratory settings, allows linked particles to influence each other instantaneously across distance. Some theorists speculate that conscious awareness could involve similar dynamics, that it exists not only within the brain, but also in networks governed by subtle quantum relationships. If such a model were true, then the failure of ordinary brain function might not fully end consciousness. Instead, awareness might continue to operate at a level less dependent on neurons. In practice, this is far from proven. What is actually being proposed is a shift of frame, from viewing neurons as exclusive generators to seeing them as possible receivers or modulators tied into deeper processes. Several hypotheses attempt to give this idea biological grounding. One of the more talked about comes from proposals that structures inside neurons, such as microtubules, could support brief episodes of quantum coherence. Advocates suggest that under normal conditions this activity remains hidden beneath ordinary neurological function. But when biology falters, such as during cardiac arrest, the underlying layer might come forward into perception. To supporters of this model, near-death visions of radiance or unity could be glimpses of that deeper field. Again, the evidence is thin. Some exploratory experiments involving differences in anesthetic effects on microtubules or isotope-related studies point to possible testable pathways, but these results are early, debated, and not universally accepted. What draws attention is how qualities of near-death accounts sometimes resemble aspects of entanglement. Patients speak of simultaneous awareness in multiple places, or of communication that requires no language. These descriptions sound similar to non-local correlations that physicists associate with quantum systems. The resemblance does not prove any mechanistic link, yet it keeps discussion alive. Some theorists argue that if non-locality already exists in physics, it is not unreasonable to suppose consciousness might also display such features. But this is far from consensus. Leading neuroscientists and philosophers caution that the warm, noisy environment of the brain is unlikely to sustain the delicate coherence required for entanglement-like states. This is why the idea remains controversial. The greatest tension lies in the risk of overreaching. Critics stress that using quantum terminology to frame subjective experience can blur metaphor with mechanism. Just because two phenomena look similar does not make them causally related. The field of consciousness research has already suffered from misuse of quantum language to justify unsupported claims. For that reason, many scientists resist extending quantum theory into this domain without clear, testable evidence. They call for caution. Mystery on one side does not automatically solve mystery on the other. And yet, physicists do not dismiss the question entirely for one important reason. Consciousness has no clear place in current models of physical reality. Classical mechanics and quantum field theory explain matter and energy with extraordinary precision, but the simple fact of subjective awareness does not fall naturally from the equations. If the cosmos ultimately requires a full accounting of mind as well as matter, some researchers argue it is reasonable to at least explore whether new frameworks might be needed. The evidence from near-death experiences does not prove anything beyond doubt, but for those who see an uncharted territory where physics and subjective reports overlap, the pursuit remains intellectually valid. Among the more ambitious recent proposals is the idea of a distributed quantum network. This framework envisions consciousness not as an isolated property of individual brains, but as a field that individuals tap into, localized nodes drawing from a shared reservoir. According to this hypothesis, near-death states loosen the biological filters that normally constrain access, briefly immersing the individual in the network itself. The frequent reports of boundless unity, instantaneous knowledge, and expansion beyond the body could then be seen as natural expressions of direct contact with that system. While such ideas appeal to those seeking convergence between physics and experience, critics argue they still rest on analogy and lack demonstrable measurements. The debate remains unresolved. Some researchers welcome the possibility of bridging physics and consciousness, while others point to the persistent absence of empirical support. Even so, the discussion grows because patient accounts consistently come back with similar themes. For skeptics, the challenge is to explain how so many people describe such repeatable imagery under conditions when the brain should be failing. For advocates, that regularity signals a pattern that may eventually connect with physical theories. Between these poles lies a cautious middle ground. Quantum consciousness remains hypothetical, in need of rigorous testing, and unlikely to replace established biology anytime soon. Practical steps toward testing these theories have begun but remain fragmentary. A handful of teams have looked at whether quantum coherence in biological structures might influence the action of certain anesthetics, producing measurable variations in response. Others have speculated about indirect tests through isotope substitution or computational modeling of microtubule behavior. None of these efforts yet delivers the conclusive proof needed, but they keep the door open for experimental approaches. For critics, the very difficulty of obtaining empirical access underscores why the idea must be treated as provisional. For proponents, even small hints of testability mark important progress, suggesting that consciousness might eventually be investigated with tools normally reserved for physics. From the standpoint of lived experience, what makes these suggestions compelling is how closely they echo what survivors actually describe. Instead of incoherent visions, patients describe ordered, luminous events, communication without sound, and a strong sense of being immersed in a larger reality. These themes resemble the properties that theorists attempt to model with quantum terms. While similarity is not itself evidence, the overlap explains why interdisciplinary conversations continue despite resistance. By positioning near-death experiences within discussions of quantum models, the main takeaway is not that physics has answered the riddle of consciousness. Rather, it is that these reports highlight gaps in current models that remain unresolved. Whether quantum mechanics eventually offers a solution, or whether consciousness requires an entirely different approach remains open. What can be said is that some of the most unexpected voices in science now treat these experiences as data points too consistent to ignore. As with all extraordinary proposals, time and evidence will decide whether they stand. For now, they remain speculative avenues, not mainstream consensus. And while quantum theories of consciousness may or may not provide the ultimate explanation, the steady recurrence of certain images within near-death accounts continues to press scientists to re-examine what awareness can mean at the threshold of life. These recurring images prepare the ground for the next layer of inquiry, where one particular motif stands out with remarkable regularity in patient narratives.